Hey everybody, I'm here with Jeff, not for the first time, but for the first time unless you've been here since probably 3 years ago, I think was the last time we did a video with Jeff about Lokinet. For those of you who don't know Jeff, he is Lokinet developer. Lokinet is somewhat his brainchild, you might say. He's a sort of resident coding genius and yeah, just overall developer superstar. So hello,
Workaholic,
Jeff.
yeah.
Workaholic is another way, a less romantic way of putting it, potentially.
It's a more realistic way, right?
But today we're going to be talking about DNS, which is the way that addressing works in Lokinet. We'll chat a little bit about how addressing works in other onion routers, why we came to choose DNS, all those kinds of fun things. So first of all, before we jump into DNS and the way that addressing works in Lokinet, Jeff, let's start with some other onion routers. So with Tor and I2P, they don't use DNS. They use different addressing systems. Can you just explain how they work?
Sure. Yeah. So Tor has two primary ways of utilizing their onion router, which is primarily they have a SOCKS proxy, which is it's a socket a TCP socket that you connect to, speak a little protocol and a handshake over that TCP connection, and then that TCP connection is upgraded to wherever it's connected to that you asked for it to connect to, or closes it with an error. And the other way is using a transparent proxy, which is sort of close to what we do in Lokinet, except TCP only. So they have a trans proxy plus DNS kind of set up in Tor, but no one uses it. Cause kind of, well, not no one. Very few people use it because it's really obtuse, and you have to know how to set up your firewall rules manually, and it's in general not very accessible. But primarily people use the SOCKS proxy in Tor because it's what people use for the most part, and it's what Tor browser uses. So that's kind of the primary interface that it can expose at the moment. I2P is not simple because they have like 5. So yeah, let's just leave it at that. Because I did used to contribute to I2P's C++ router, and there's more ways of doing it than there should be. And I think that's really where the motivation for using DNS came from, is that I just want one way to use this and have it be the way that every single application knows how to use without even caring it's there.
Yeah.
That's kind of one way to kind of explain the ethos of why we chose DNS and Lokinet, because the protocol is kind of meh, but like everything speaks it. So, I mean,
Yeah. So for those of us in the audience, or for me as well, who don't have a firm grasp on what DNS actually is, or what we mean when we say DNS, can you just give a brief overview of what DNS is?
Yeah. So DNS is a protocol that you give it a name, which is effectively just a list of labels, which is, words, basically, a list of words, ending with a .com or .net or .whatever. And you have all these, you have a name and you want to resolve it to an IP address. So what you do is you ask your local network's DNS resolver, hey, what is the IP address for this name? And it gives you back the IP address for that name. However, there's a lot more other things that you can do with DNS, not just name to IP, but name to other kinds of records. So it's basically too long didn't read edition. You are resolving name to IP.
Right.
So like google.com to IP or something like that.
Yeah. So like we were saying in the past, DNS hasn't really been used with other onion routers for addressing. Why exactly was it so unpopular?
Because setting the DNS resolver is a very platform-specific thing, and even in Linux, there's 5 different ways to do it, and every single specific machine you're going to run it on, whether it's a Windows machine, is different from a Mac machine versus if you want to have it be on your local machine, and have it like you're running this program locally and you want to set the DNS to go to this local thing. That's hard. It's really hard. And a lot of the existing onion routers assumed that you're going to be running this thing 100% of the time on your local machine because that's kind of how they were designed. Whereas Lokinet was designed from the get-go to run on a Soho router or your Wi-Fi router, if you wish, if you will, and it would tell the local network, "Hey, your DNS server is me here," and that would be Lokinet DNS. And that use case of running Lokinet on your Soho router is kind of where like the idea of using DNS came from as well, is because then you can have this local network where the default settings is just to use Lokinet DNS. You just connect your computer to that network, and everything just works. You don't do anything at all. And that's kind of the primary best way to use Lokinet.
Yeah, and we've seen some examples with that. Community member, Technical Tumbleweed, made a device called the Lokinet AP, which I think is similar to what you're describing there, Jeff.
Yeah, I have one right here on my desk, but it overheated because I was sending lots of traffic over it and decided to turn itself off from being hot. But that's kind of the primary way I use Lokinet in general. It's just via an external device because it's so much easier.
Excellent. So with all of this in mind, right? So, DNS hasn't really been adopted by other onion routers. We're setting out to make an onion router. How did we come to the conclusion that DNS was the way to go?
I mean, for me, it was a process of elimination. Because I, in the past, used Tor and ITP like extensively, I understood how all that stuff in there worked, and all of the pain points in I2P. They're trying many different things to see what is the nicest way to interface with our network, and all of them were pretty. They had their trade-offs, and some of them were like, I don't want to use this. And at the end of the day, when you use DNS, you can make the IP addresses go to whatever you want, and that gives a level of flexibility where, specifically in the case of Lokinet, you don't have to have like a globally agreed upon IP range that you're using. You just have your local kind of configured, I want to use these set of IPs for Lokinet addresses, and then your DNS will auto map them onto those ranges. And that just, after a few kind of considerations of how to do addressing, it just seemed like the least painful way, despite DNS being really painful.
So what I'm hearing here is that making an onion router is kind of a painful process.
Yes, but also it's more of like, keep in mind, this is like the fourth iteration of what I was trying to make, and like it just happened to get picked up at the time. So I have tried other approaches for addressing, and they kind of sucked. So
yeah, do you want to briefly go through some of the other addressing approaches that we tried out with Lokinet?
Yeah. So one of the more popular ones was to squat on a very large IP6 range, and then have everyone agree on a mapping from a public key to an IP6 address. That works. It's just more complicated when you only have an IP address. How do you get their public key? You need to have an entirely separate kind of lookup mechanism for that, and that's what Yggdrasil does, but it's really painful to implement. And that project, Yggdrasil, only does that effectively, along with routing and all the other stuff that they do. But realistically, the biggest kind of, it's a lot of stuff you have to add to make that work, and I just didn't want to do that. Then there's the other approach of just use a SOCKS proxy. Then you're limited to TCP and maybe UDP, but no one really does SOCKS 5 UDP integration that much, because I actually haven't seen a SOCKS 5 proxy implement UDP forwarding. So I'm sure there's one out there, I just haven't seen one. Then the other way you could do it is insert custom proxy protocol here, and just no one supports that. That's kind of the three other flavors that ITP does, and no.
So when you have that lack of support, I guess that eats into one of Lokinet's biggest strengths, which is, its ability to just integrate into anything.
Right, and like it's kind of taking the inverse approach of kind of the ITP way, which is ITP way is you kind of embed a ITP router into your application manually, and you code up all the stuff and wire it up, and that severely hampers adoption a lot, and a lot of development time is just spent porting applications to work with that, and it's just like no one wants to do that. They want it to go, and realistically, you don't want to have your application care that is going over an onion routing network. You just want it to go, for like usability's sake. But also, I do understand the argument of wanting to manually glue in a network layer into your application, because then you can really tailor and fine tune the fingerprint and all that stuff that you have when doing that. It's just good luck finding enough developers to do that.
Yeah. So after all this preamble about what other onion routers do and why DNS hasn't been used before and how we came to choose DNS.
Well, it has. It's just not popular. That's
How does addressing in Lokinet actually work with DNS?
Sure. What happens is that, let's say you're in your web browser and you type in probably .loki, right? What happens is that your browser is going to look up, hey, what is the IP address of probably.loki? And given you're running Lokinet or on a Lokinet-enabled network, you're going to send a DNS query to a Lokinet-enabled resolver, which is probably just a Lokinet. It'll get that query saying, hey, where is probably.loki? So what it does is it does a bunch of lookups on the network. Given probably.loki, that's an ONS name, so it has to do an initial extra step, which is, hey, network, what is the .loki address of this ONS name? So it does that. It fetches it back from the network. Now that we have the .loki address in full, we establish a flow to wherever that is on the network via lookups, etc. Internal implementation details users don't care about. Usually happens within a half a second or so, depending on your internet. And once we know that we can send packets to wherever this is going, we send back to to the requester of this DNS query, hey, it's at this IP address. And at that time, we associate a IP address that we have on the Lokinet network interface to go to this .loki address, and then we send it back saying, hey, whatever this is, .loki, is mapped to this IP address, boom. And now, whenever you send IP packets to that IP address, it's going to go over Lokinet automatically on the way over there. So it's if you omit the internal implementation details, it's basically you ask Lokinet, what is the IP address of this guy? And it gives you back the IP address, and you just talk to that IP address, and it goes. And from the application's perspective, it doesn't know it's going over Lokinet. It's just another domain on the internet as far as it cares.
So when you say, it returns this IP address, whose IP address is that it returns?
That is an IP address owned by Lokinet, and that's it's defined. So when Lokinet starts up, it guesses, given the network it's on, what private IP range it can use for mapping stuff. We have a bunch of private ranges we try. We use the first best one. And it's usually like a 712.16/16 or something. But like some networks use that, so it'll go to a 10/16, etc. And if it can't find anything, it'll just say, hey, we don't have any available ranges that we can use, and it bails and crashes. Not crashes, it just shuts off and says, we can't find an available range. But yeah, it's basically a user-defined IP4 range, and it will try to guess which one it can use on startup.
Okay.
And the point is that these mappings are ephemeral, which is also good to map with DNS, because then we can say in the response, that this mapping lasts for this long. So you could, in theory, in the future, do multiple different kind of IP mappings if you want to rotate your .loki address on your side on a time interval or something.
Mm-hmm. So those mappings are constantly changing, moving pieces.
They can, but at the moment they persist until you reboot your Lokinet.
Right.
But it gives us the flexibility to do stuff like that in the future if we want.
Yeah. The benefit of which would be presumably.
So the benefit would be that you can given one other end .loki, you could probably have it so that every minute it will rotate its .loki address on our end and give you a different IP address. And given whatever IP address it's using at the time, it will use a different .loki address on our end. And it's a completely transparent way to kind of do not really stream isolation, kind of a flow isolation, sort of in the future. There are other ways to do it, like with IP6 flow labels, but that's way in the future.
Yeah,
for the most part.
Well, if that makes sense. Any finishing comments that you want to make about DNS or DNS on Lokinet or other addressing systems or the future of addressing on Lokinet?
Yeah, so one of the biggest issues right now in Lokinet with DNS, we don't really have a good upstream DNS provider to default to. So I've given up and said, let's just use Cloudflare. I hate that. And I in the future really want to put into the service nodes some kind of requirement on maybe using something like DNS crypt so that we can make it so that you just ask a service node and it will speak DNS crypt to another service node and then proxy this DNS request out. So we don't need to care necessarily and pin to one upstream DNS provider. We could have all the service nodes be potentially encrypted DNS providers.
Wow, so you would effectively turn the service node network into a DNS provider.
Yeah.
Oh, wow, that's cool.
I'd like to. So the problem that you have to think about there is because there's so much geodiversity, none of the we can't really cache any of it because that's just going to end horribly. Additionally, it's a really hard problem because how do you know the response is correct unless you're going to use DNSSEC? You don't, and it becomes very, very hard to like verify correct operation. If everyone's a DNS resolver, how do you know if it's operating correctly or what is correct operation with DNS anyways? Because it's different regions of the world give you different like DNS results because of geographic load balancing. So you can't really have a consensus on what is the correct mapping for this entry. So if we were to provide DNS provider in Lokinet service nodes, that's going to take a lot of research, but something I would love to eventually do. But I don't know. It'll take a while to figure out. Maybe we could cache using ONS.
Potentially.
You could burn your not really burn, but like you say, oh, given that instead of looking up. So the way ONS works now is you hash the DNS query name you're sending. Like if you have like whatever.loki, you hash that and you use that digest as a key to ask the service node, give me the entry for that. But the service node doesn't know what the TLD is at all. So we could, in theory, have it so that the service nodes have a DNS cache by ONS hash or something. Maybe, I don't know. It's just, there's a lot of things we could do because we have the service node network, and that opens up a lot of cool things we could do in the future. And I feel like a lot of people miss that sometimes.
Yeah. Well, I think that pretty much covers everything for today. But it sounds like there's a few more talking points that we should cover in the future, Jeff. Sit down and have some more chats about Lokinet. if we can pull you away from your dev work for 20 minutes at a time. But yeah, thank you so much for talking with us today, Jeff. It is a pleasure to tap into your knowledge about Lokinet. It is truly an endless well. But yeah, it's been great.
It's pretty deep. there is a bottom, but like I don't know if it.
I don't know where the bottom
how deep
is.
it is. It's somewhere there, right? Eventually, right?
But yeah, thank you so much. Thank you everybody that's watched, and we'll see you next time.